Hello everyone, my name is María Serrano-Mesa and I will be presenting today experimental investigation on prestressed thin-walled concrete folded slabs with CFRP Textiles. My co-authors are Juan Pablo Osman-Letelier, Hückler Mike Schlaich from the Technical University of Berlin. Our main motivation for this paper is the fact that cement production is responsible for around 8% of global CO2 emissions. For this reason, our goal was to create structural elements which are durable, lightweight due to low material consumption, and thus more environmentally friendly, such as concrete folded slabs prestressed with carbon fiber reinforced polymer textiles. Our design is based on the numerous prestressed thin-walled concrete structures constructed more than 50 years ago. Here we can see an example from the year 1968. Thanks to the corrosion resistance of CFRP, among other advantages, these highly efficient elements are possible again. For this purpose, pre-stressing criteria were developed at our institute. The diagram shows it schematically using the moment-deflection relationship of a simply supported beam. The first criterion bases on the Eurocode 2 and states that the degree of pre-stressing must be set high enough to avoid deflections greater than L divided by 250 under the quasi-permanent load combination, including long-term effects. The second criterion guarantees a failure warning defined by deformability. In this way, when the maximum design moment in IASS is reached, the deflection should be larger than L divided by 100. These folded slabs were used as a garage roof with infra-lightweight concrete walls. They have a section width of 1.2 meters and a length of 8.71 meters. On the right side, we can see the cross-section with a maximum thick of only 4 centimeters. In order to study the structural and deformation behavior, a 4-point bending test of a folded slab was carried out. Considering the experimental results and the long-term theoretical reflection, it can be observed that both criteria are fulfilled. On the other hand, the theoretical deflection of the same design, but with a slight reinforcement, will be significantly larger, roughly 7 times bigger. This means that even without considering long-term effects, it will not fulfill the first criterion without prestressing. For the long-term test, the deflection under superimposed loads was measured. Parameters such as temperature and humidity were recorded, and the experimental elastic modulus of concrete was determined. Besides superimposed loads, following effects were considered: the increase of deflection due to concrete creep and the deflection caused by shrinkage of concrete, which are calculated according to Eurocode 2. For the last deflection term, due to prestress losses, the Canadian standard was used since it is the most recent standard for prestressed carbon concrete. Both experimental and numerical deflections are illustrated in this diagram, showing a conservative estimation with an average difference smaller than 6%. Both figures show the constructed garage. On the left side we can see the inner view, and on the right side the outside view. Another feasible application could be slab elements for buildings. After adapting the design to building loads, it was compared with a typical conventional 30 cm thick slab and a prestressed hollow core slab. As a result, material savings of about 70 and 45% were obtained respectively. Within this paper, prestressed CFRP textiles were used to create very efficient structural elements. For the developed concrete folded slabs, prestressing led to a more than 80% reduction of deflection in SLS. We could validate the existing models to estimate long-term deflection, and a roof of 8.71 meters span, with a cross-section thickness of only 4 centimeters, was constructed. These elements showed a great potential as slab elements for the building industry, but further investigations on shear capacity are needed. Here you can see the references. If you have questions or want to discuss further this topic, please don't hesitate to contact me. Thank you for your attention.